Hi, my name is Jesus Salado, and we're here representing the Bourns College of Engineering at the University of California, Riverside. Our research group is thrilled to be participating in the 16th annual P3 Expo, focusing on designing solutions for a more sustainable future. Our project focuses on converting crop waste into a usable construction material. Our focus is on two objectives. One, creating a process to convert wheat straw crop waste into a structural fiber that can then be used in the creation of panels to replace traditional gypsum drywall. We also need to be able to obtain a good comparison between the wheat straw panels and their gypsum-based counterparts. So our second objective will be to evaluate several key properties of the material and in order to assess how viable these panels will be for use as a construction material.
So this is our block flow diagram, and how our process works is that we gather wheat straws from farms that no longer need it and put it through a shredder to cut it down to size to about 2 to 3 centimeters long, and then we treat it in hot water to soften the straws and weaken the ligand. And then we put it through a refining process where it will be digested in cooking liquor, which consists of potassium hydroxide and diluted ammonia, and as well as treating it at elevated pressures. But during the refining process, black liquor also gets created, so we have to put it through a screening process where we separate the pulp from the black liquor, where the black liquor will get recycled back into the refining process, as well as wheat straws that weren't cut down to size or that are more than 3 centimeters long. And both of these components will simply be uh, repeating the process of the refining process until it makes it through the screen. And once it does, both the pulp will be put through a filter or a rotary vacuum where it'll separate the pulp from the fines and black liquor, where both the fines and the black liquor will be considered byproduct and will be sold for profit. And the pulp that does make it through the rotary vacuum will be placed into a mixture where it will be mixed in with liquid resin and additives, which are sawdust, wax, and fiberglass. And once everything gets mixed in well together, it will be put into a hot press where it will repeat the process 3 times. Where the first hot press will be or after the first hot press, it will be cooled down through a fan, and then for the second and third hot press, it will just be cooled down through room temperature until we get our final product. And then we have the process flow diagram, which is based on the block flow diagram we created. And the key things to look at is the product streams, the recycle streams, and the water streams. And the important thing to note is that the water that we use is used to recycle and to generate energy to save on energy costs, as well as the recycle streams to help us save on raw materials and to use every bit of raw material that we use to get our final product.
I'm a senior studying material science and engineering here at UCR. Something we need to focus on in the portion of testing is to determine the mechanical properties of the wheat straw panels. This will tell us how the material will react to different loading conditions. Here's the scope of testing that we are doing, as well as how each is related to standards that are used to evaluate gypsum drywall currently. We need to be able to meet the strength and durability requirements of gypsum panel products in our wheat straw panels. And so this portion of testing will evaluate the structural integrity of the panels under different loading conditions using these testing standards.
Hi, I'm Kenji, a fourth year material science engineering major at Bourns College of Engineering at UCR. And for this project, I'm focused on the industry thermal property testing, which entails fire testing, thermal resistance, thermal conductance, specific heat, and non-combustibility. This is inherent to know since drywall is a known flame retardant during house fires, and needing to contain or diffuse fires may save lives in the future. It's our goal to test if the prototype wheat straw can withstand such conditions and possibly surpass traditional drywall.
Hello everyone, I'm Yeyi, and I'm a fifth-year material science and engineering major student at UCR. I'm responsible for the chemical property testing in this wheat straw-based drywall testing project. which includes the gas emission testing, gas absorption testing, the acid resistant testing focusing on carbonic acid from rainwater, biodegradability testing, and the accelerated aging testing. The ability of this prototype withdrawal-based drywall to pass all these tests I mentioned above is crucial, considering the health and safety of the people who are using this type of drywall in the future.